Okay, here we are taking the example of abstract class and the abstract method. So we have simply taken one class, parent class. I declare it as abstract by using abstract keyword over here. Okay, exactly same way I have written one constructor for this class. Okay, this is non-abstract method and this one is abstract method. Okay, this is the abstract method without body. Okay, now if I go to this test abstract class, and here if I try to create object of abstract class, if here I try to create a object of abstract class, it is simply giving the error, cannot instantiate the type of parent, cannot instantiate the type of parent. Why? Because parent we have declared it as abstract, and abstract class cannot be instantiated. Okay, so that is what this one problem. So we can't write like this. Okay, then if you are not able to create object of a parent class, then what is the purpose of declaring a parent class as abstract class? Then we can say that abstract class will always inherited by child class. Abstract class will always inherited by child class. That means what? Abstract class will act as the parent class. Abstract class will act as the parent class. Okay, so I want to make this relationship. So I have created this one class. Class child extend the parent. Class child extends parent here. So if I do like this one, so compulsory I have to declare. Compulsory I have to define, I can say, not a declare. I have to define all the abstract methods in this. Okay, so that means that I have to override abstract methods from the parent class. And if I am not doing so, it will give the error at the compile time itself. You can see here, because I have put it this one in the comment, it is showing the error that the type child must implement the inherited abstract method parent.display. It is showing a parent.display. That means that you should have defined that abstract method. Otherwise, you can declare this class as abstract. So I can see, I can write like this one. So I declare this one class as abstract, and you can see there is no error in this line. Okay. So now, but I don't want to make my child as abstract, so I will put this one. So for that purpose, I have to define all abstract methods. So I do have only one method abstract in a parent class. That is what the display. So I will override that one. I will just put this one. Okay. So this is what I have written. With this one, I can have my own method. I can have own method. Child class can have own method. Public void. Okay. I can say put data. Okay. I can have this one method. Put data over here. And in that one, I just try to write sys out. In child. Okay. I can say put data. In a child, put data. And here in a child, display. This is what the overridden method. This is what the overridden method. Okay. So this is what the concept exactly. Now you guys need to remember one topic which already we have discussed while taking a dynamic method dispatch. There we observed that parent class reference variable can refer, parent class reference variable can refer object of, parent class reference variable can refer object of child class I can say. So I am this same thing I am trying to do. So that means what, even though my parent is abstract, I can create a reference variable. So I will just write like this one, parent ref, you can give any name. I'm doing like this one. And now I will write ref is equals to new, and I will make it as a parent. I will make it as a child. So by doing this one, see, where ref is of type of parent, but I am creating object of a child, and you can see it is not giving me any error. Okay, then through that one, I am calling ref.display. Now it will go to the child class display, because even parent class don't have any body. parent class don't have any body, so there is no problem, there is no use to invoke that one method because it is without body, so it will always go to the child class. Okay, here I can write like this. Excuse me, ref dot, I can write here show. Okay, it is, I'm calling like this one because it is been inherited in a child class. I can invoke like that. Ref dot put data. Okay, ref dot, I'm just trying to call this one put data. Okay, but it is not invoking, it is not available over here. It is giving the error over here. Why it is giving the error? Because put data is not belongs to the parent class. So original method of a child class cannot be accessed by using the parent reference variable. We already have been discussed about this one. So for that one compulsory I need a child class object. So now I will try to execute this. Now I will try to execute this. And you can see here, okay, because other class is having the error, so it is asking us to proceed further. And you can see it is went through the parent constructor, it went through the in child display, and it is going to the in a non-abstract show. It is non-abstract show. So this is what exactly the concept here. This is what exactly the concept here. Okay, so we are calling the show refer ref dot show. We are writing like ref dot display. Okay, we are calling by using the parent reference variable. Parent reference variable. It don't know which display how to be called, because there might be chance that this parent class will be get inherited by any other class too. Other class too. So for example, just I will create another one class child one. This is simple child I have created. I will create another one class. Okay, child one will be there. Okay, and in that child one, okay, again I will make the relationship as a extends parent. As I'm doing like this one, compiler gives error. Okay, because we have not implemented, so I will just implement that one, override public void display. Okay, directly we can do that one. And here I will write one method sys out. Now I am in display in a child one display. Earlier I was only in a child display. Earlier I was in only in the child display. So I'm doing like public void display child one. Okay. So if I do like this one and I went to the this one, now here I will create a ref is equals to new, ref is equal to new, and here I will write a child one. I will write a child one, and then I will call ref dot display. And you can see both this one display statement, this one statement number at line number 13 and a statement at line number 9. Both the statements are exactly same, but still line number 9 will call the child first one. Okay, that is what this one class display method, and this one will call a child one display, child one display. So you can observe this. If I call this, okay, proceed, you can see child one display and a child display. So that is what here. So through that one we are achieving a runtime polymorphism. So one more statement I can say about abstract keyword. Okay, here we can achieve runtime polymorphism. Runtime polymorphism. So this is what we are achieving, because both the statements are exactly same. Both the statements are exactly same. Still, it is invoking the different version of the display method. So it is deciding which version of that display how to call at a runtime, not a compile time, and hence we call it as a runtime polymorphism or a dynamic polymorphism, I can say. So here I can write again about this one. It's used to achieve runtime polymorphism. Runtime polymorphism. It is used to achieve a runtime polymorphism. Okay, and here actually what we are doing here, simply see, we are putting the abstract method over there. We are putting the abstract method over. So the here actually we are making the method as abstract. That means what we are putting this as a hidden from the other world without a body. Whenever we are, it is thinking that we are calling that method through the, parent class reference variable, but according to the reference of child class object, it is invoking that one. So invoking the person, okay, invoking interface will not aware about which version this statement will go to, the which version of that display method. So it is, we have put a hidden from the outside world. So this call will go to the which version of that display. Okay, so here we are putting it as a hidden, which version we are calling. So again, the concept of abstraction is what? The things which are essential, that will be made available, and non-essential things will be get put hidden. So here that hiding we are doing, and that hiding is nothing but the abstraction. So here we are achieving a abstraction mechanism. Here we, it's used to achieve, it's used to achieve 0 to 100% abstraction. 0 to 100% abstraction. When 0, if all non-abstract methods are there within a class, all non-abstract methods are there in the class, then it is a 0% abstraction. 0% abstraction. And if we have all abstract methods in the class, then it is 100% abstraction. And in between that, we can like 2%, 3%, 4%, 50%. If we can say 50% abstraction means what? Half of the method are abstract and half of the method are non-abstract. And that is what we call it as the 0 to 100% abstraction. 0 to 100% abstraction will be get achieved by using this abstraction mechanism or abstract class and abstract method. Yes, clear?
Oh, sir.
Any doubt?
No.
Okay.
No.
So this is what the example here. This is what the example, okay, of this abstraction mechanism. I will just go for another one example for this one. Another example for this one. Assume like I do have a shape class. I do have a shape class. Okay, and shape, it is the generalized term. It is the generalized term. Okay, so in that shape, I will put one method. I will put one method as an area. I will put that method as an area. But here I can't write the body because I can't use the formula, because shape can be circle, shape can be rectangle, shape can be cone, any. So here it how to declare as abstract. Here we have to declare as a abstract. Then this shape class will be get inherited by circle. Okay, in the circle, and in a circle class we will write a area. We will write a area with what is the formula for that? It is the pi r square. That is what 3.14. Here we can say 3.14. That is what the pi value into r square. That is what the radius, I can say. Radius into radius. Okay, this is what the one formula for circle. And if you say about a rectangle, okay, in a rectangle, I can consider area again over here. Okay, for the rectangle too, I can consider the area. Okay, here the area will be, yes, L into B. L into B. That is what the length into breadth. Length into breadth. So shape class will be get inherited. Shape class will be get inherited by these two classes. Shape class will be get inherited by these two classes. So I have to put this area as abstract because I can't here what? I can't write here a definition for that. So it is what the abstract. So this shape class I have to declare as a abstract class. Shape class I have to make it as a abstract. Then that shape class will be inherited by circle. That shape class will be get inherited by rectangle. Okay. And here we are going to override that area method. Okay. So what it doing exactly here? It is simply forcing. See, abstract class, what it is doing? Abstract class forces its child classes to implement or define all abstract methods in it. So that is what it is doing through this one: shape class, circle class, and the rectangle class. So I can write this area over here, and this area will be get overridden in this one. Okay, we can say that I will try to define this one method, this one implementation here in this. Okay, I just close this, close all. Okay, save all, and I will just go for here new class. Okay, I will write here shape. Any shape can be there. Okay, finish. And in that one, I will put 100% abstraction. There was a 50% abstraction earlier, but here I will write 100% abstraction. Public void. Okay, area method. Okay, and here that I will make it as abstract. Okay, so by writing this one is not enough. So I have to use abstract keyword over here. Abstract public void area. Public void area. But what is the rule over here? If class having abstract method, then it must be compulsory abstract class. It must be compulsory abstract class. Abstract class like this one. So it is what the very simple I created the class. Now I just want to go for circle class. Okay, circle. Oh, sorry. I will just going to create a new class. Okay, there will be a circle. Okay, circle, finish. That circle class will extends, we can say shape. So if it is like that one, we have to override that method. So I will just write a public void area. Okay, and in that area I will define that method sysout. Okay, here area of circle equals to, and here I can say 3.14 into r into, we can say r. That is what the radius. So I have implemented this one. I am not going in the implementation, just I am showing this one. Okay, exactly same way I will go for another one class. Okay, there is the rectangle. In that rectangle class, here I just simply write extends shape class. Okay, as it is doing, it is showing the error. So I can write public void area. In that one, I will just provide the implementation for that sysout. Okay, area of rectangle is equals to L into B. Like this one I tried. Okay, very simply I did. This was the 100% abstraction. And then I just go for the new class. Okay, then new class, test shape. I will write the shape. Okay, then circle and rectangle, so that it will be get understandable. So here I have done this. Now when I go to this one class, if I try to create object of a shape class, shape obj is equals to new, and here I have written the shape, it will give us a error. It is simply like we can't instantiate because it is the abstract class. Okay, so it will give the error. So I just put this one into the comment again. Okay, now, but I can create the reference of that one. I can create the reference. So shape ref. Okay, I just have written like this, and then I will write ref is equals to new circle. Sorry. Okay, and here I can write ref dot area, and it will invoke circle version of the area. It will go to the circle version of that. It will go to the circle version of that. Okay, and exactly same way, I will go for ref is equals to new. Okay, and rectangle. Okay, and here I will write ref dot area. Okay, and now it will go for the rectangle version of that one. So it is what the runtime polymorphism we can say. It is what the runtime polymorphism. This is what exactly the abstraction we are achieving. 100% abstraction. Okay, just proceeding, and you can see it is going for area of circle and the area of a rectangle. Hope it is clear now.
Oh, sir.
Okay, so while doing this one, you have to remember these features compulsory. We can't create object of abstract class. Okay, but we can create the reference variable or the variable of type abstract class, and that can be referred. Okay, object of all the child classes. Then abstract class can have abstract as well as non-abstract methods. If class have an abstract method, then it must be abstract class. Okay, it can have a constructor, it can have a static as well as final variables. Abstract class will be inherited by child class. That is, abstract class can access the parent class or the base class. If a child inheriting the abstract class, then compulsory it have to define or implement all abstract methods in it. Otherwise, child itself have to declare as a abstract. That is, override all abstract. And there are the two purposes we can say. It is used to achieve a runtime polymorphism, and it is used to achieve a 0 to 100% abstraction. So that is what we can say about abstract class we have already observed. And if we have to declare the method as abstract, I need to write this abstract keyword. Okay, this method without a body is nothing but abstract method, and abstract class we can declare it as abstract by using this one. Okay, but if you declare abstract class, not necessary there must be abstract method. But if class having the abstract method, then it must be abstract class. That is what the thing we need to understand. So this was the very basic thing about the abstract keyword. Okay, hope it is clear now. Yes.
Oh, sir.